connecting with us. And I give right now to the next talk of Minko. Connecting to San Francisco, USA, famous for its year-round fog, iconic Golden Gate
Y las
Bridge, the
coloridas casas
streetcars,
victorianas.
and the colorful Victorian houses.
Desde allí nos acompaña Minko
From that
Gechev,
city, we are
senior
joined by
developer en
Minko
Google y
Gechev,
cofundador
senior
de
developer at Google
Rhyme.com.
and co-founder
Él
of
nos hablará
Rhyme.com.
acerca del actual estado de
He will talk
Angular
about
y
the
su
current state of
infraestructura de
Angular and its
herramientas.
tooling infrastructure.
Okay. Hi, Minko. How are you?
Hello, I'm great. Thank you for having me today.
No, wow. Thank you for being here. So great to have you. Such an honor. And yeah, really, really cool. There are more than 900 people watching us at this moment. So
that's
It's
awesome.
a huge honor. I guess everyone knows you, but if don't, Minko is one of the brains behind the Angular team. He's a huge open source contributor and also an entrepreneur, right? You found Unsold Rhyme to Coursera.
Yeah, that's right. We did that in 2019, last year. Or actually,
Wow,
it was 2018. Mixing
That's
up years
awesome,
now.
man. So, okay, thank you very much for your contribution to Angular, to the community, for being here, and please enjoy the stage.
Thank you. I suppose you see my screen fine now?
Yeah, we do.
Awesome. Okay. Yeah. Hello, everyone. My name is Minko Gechev. I'm working as an engineer at the Angular team at Google. So my day-to-day job is pretty much to work on Angular. Today, I'm going to share with you what is the current state of the framework and like the entire product that we have been working on. Alfonso had a really amazing technical talk. I really enjoyed it. Today, in my presentation, we're going to go on a more, like, let's say, higher level where we're going to discuss primarily the technology, like in breadth. We're going to make a summary of the current state of Angular. We're going to look at some of the theoretical foundations of some of the decisions that we made in order to build Angular the way that it exists today. And at the end, we're going to focus on the roadmap and a couple of projects that we are up to right now and a couple of efforts that we'll be working on in the future. Since this is an Angular conference, I'm pretty sure that I guess every one of you is already familiar with what Angular is. But since we're kind of in a unique position to be providing an entire platform, I want to just provide a very quick summary of the individual building blocks that we provide for the development of scalable applications. So we have the framework in the core. This is something that we're spending a large portion of our time working on. The framework provides you with different primitives for developing user interfaces, and probably the most essential one is a component. If you know how to develop Angular components, well, you can already build Angular applications, and that's all you need to get started. Of course, around it, we also have different ways to inject dependencies with our dependency injection mechanism, and we are very opinionated on best practices. So in order to develop Angular applications, you would have to understand TypeScript as well. Our team is also responsible for building the Angular CLI. That provides you with a quick way to bootstrap Angular applications, and we also have a set of components and their material design implementations, and a variety of other modules. Just like Alfonso mentioned, we have server-side rendering, internationalization, and so much more. These are all well integrated with the framework since, well, they're developed by the same team at Google. So we're making sure with different integration tests that they play well together. And it has been a really long way to be in the stage that we are at right now. Currently, we have hundreds of thousands of Angular applications outside of the company and over 2,600 projects only inside of Google. So Google is a large company and Angular is heavily used, but it's really hard to measure also what impacts the framework has been having outside of Google. Today, I want to share some of the pieces of this journey, but since I really love theoretical computer science and compilers, I wanted to do it in a more theoretical way. So we're not going to talk about algorithms or different formulas. We're primarily going to focus on some trade-offs that actually have their meaning even in real life, not only in the development of compilers and frameworks nowadays. I really like to focus on these trade-offs when I'm talking about Angular, because I think that Angular is probably one of the few frameworks right now that is in a position to be actually impacted by these trade-offs, because of the way that we are offering you to develop Angular applications. We have this compiler that sets some constraints and makes the development of Angular applications more predictable. Although this predictability has its own pros, a lot of benefits that we're going to mention in a little bit, it also sets some constraints, for example, in terms of flexibility. But let us look at predictability versus flexibility in the context of real world, just in a day-to-day life. Let us suppose that we have our day-to-day schedule, and we just make our day-to-day schedule really predictable. So in our calendar, we have appointments for like waking up. We have an appointment for like having a breakfast, like going to the gym. After that, going to work for a certain period of time. Our meetings are really well scheduled. And right after that, even our time at home is really well scheduled, really tightly. So this will clearly allow us to have a really well optimized day, right? We have specific times for different activities. And if we're disciplined, we will be able to achieve all of them and, well, optimize our time to be most productive. But at the same time, we wouldn't be too flexible. We wouldn't be able to just add a new activity without planning it ahead of time. So this is just a great trade-off that we have as human beings. We can be either very predictable with kind of reduced flexibility, or too flexible without being too predictable at the same time. In the world of compilers, usually people are referring to this set of trade-offs as static versus dynamic. Static is usually just a way to like analyze your source code ahead of time before you ship it to production. So having a static system means that a lot of the different components of the system are known ahead of time before they actually get into usage in the user's browser, let's say. Dynamic systems are like very flexible. But in order to give you a better understanding of these constraints, let's put some different programming languages on the axis. A good example for a very static system which provides a lot of compile time guarantees is the Idris programming language. So this language is pretty academic. There are some real-world applications of it, like someone developed like sophisticated systems for like just like sending messages over the network, let's say. But it is hard to develop real-world applications because of this very strict compiler that wants everything to be known ahead of time, even before we compile the program. A good example, which you might be even more familiar with, is Haskell. It has a super powerful type system. And making sure, like running your program through the Haskell compiler and making sure that it type checks, it almost guarantees you that you're not going to have runtime errors. Rust is another such example. In Rust, your type system is even guarding your memory usage. So you're not going to have any memory leaks if you have a program which type checks well. On the other side of the spectrum, though, we have Ruby and JavaScript. These programming languages are extremely dynamic. You can very easily prototype new systems with them. There is no compiler there that is guarding you to just like not shoot yourself in the foot. But at the same time, they don't provide you with enough compile time guarantees that your programs are correct. So over time, when your software starts growing a lot, you need something that makes sure that you have fewer runtime errors. And that is how TypeScript showed up. TypeScript has a type system that is guarding us to not just hit some very frequent errors in our day-to-day development process. It is TypeScript provides a good balance between static and dynamic, where we have a compiler, which is relying on some static guarantees that are only applicable at compile time, but also it is not too static. It is not as static as Idris, where we have super restrictive and super powerful type system. Now, there is an interesting trade-off here as well. If you start with a very static system with something like Idris, where you have a lot of constraints at build time and everything should be well known before you ship your application to production, everything should be well known before you actually even start building your application in order for it to compile, it is very easy to drop some of these constraints and make your program more dynamic. Imagine you have a very strict TypeScript program which is following the strictest possible compiler options, such as like strict no checks and so on and so forth. If you want to make this program more dynamic, you can just drop these constraints. You can just strip all the type annotations that your TypeScript program has, and this way it is going to become just the equivalent JavaScript program. However, if you have a very static, very dynamic JavaScript program, which haven't been type checked like at all, it is going to be harder to make it very static. It is going to be harder to convert it to TypeScript and enable the strictest possible TypeScript compiler time options. Because if this system gets even bigger, you may even have to refactor your source code in order to make sure that it type checks properly and it works well with, and it plays well with the TypeScript compiler. So this static and dynamic thing, this may still sound quite abstract, but let me show you just different features that static systems have compared to dynamic ones. For example, with static systems, since everything is known ahead of time, you can perform different compile time optimizations. You have this compilation step where the compiler just can take your program and transform it to something more efficient, to a more efficient version of itself. You have strict type checking, which guarantees correctness of your program. So just by having this compiler to tell you that your program compiles, this means that you have already eliminated some of the issues that your users may face at runtime. And in the case of Angular, our static system allows us to have zero overhead internationalization. Of course, this comes with its own trade-offs. With static systems, we need to have a build system. We need to have a build time in general. But with dynamic system, well, we don't have any compile time guarantee, so we may just drop the compilation step. This way, we're going to have super fast development process, so we can prototype really rapidly. We're not going to have this build time. We don't have ng build where we would have to wait for a couple of minutes for your output to get into the disk directory. But at the same time, you're not getting some of the guarantees that the static systems provide. See how interesting it is. You're getting some from each one of these two worlds, but you probably cannot get all of that. This is a trade-off which is very interesting in computer science, and there is not a really right answer for what is the right approach to go with. I guess if you get a system somewhere in the middle, this could be a good system that satisfies the user needs at a certain period of time. But again, web systems and business in general evolves. So this right place onto this axis, it will vary a lot depending on the evolution of the business as well. So this is a thought, like it's like very narcissistic, I guess, to quote myself, and I'm definitely not the first person to come up with like this conclusion. But it is good to get build time errors, right? Because if you get a build time error, this means that you have had something broken in your program at the first place. So when you get this build time error, this means that you're going to fix it and you're going to ship a better program right after that to your users. And this error is not going to be something that your users should be concerned about, right? Because you have already fixed it since your compiler told you that there is something wrong in your program. So having this compiler to guard you is going to save you a lot of time fixing errors reported by your users after that. But it is still to put some quantitative measures of how many errors the compiler is going to help you to catch ahead of time, right? So some folks from Microsoft and from the academia, they looked at different open source projects on GitHub. They pretty much just opened their issue trackers. They looked at all the reported issues there from the users of these projects, and they tried to predict how many of these errors would have been detectable by the TypeScript type system if these JavaScript projects were actually written in TypeScript. This means that if the TypeScript type system have called these errors ahead of time, these errors were actually never going to be like caused any trouble for the end users. The end users would never have to report them in the issue tracker, and developers to spend like countless of hours debugging and fixing them afterwards. So according to the findings of this paper, about 15% of the bugs in the projects that were explored were detectable at build time. This means that with TypeScript, you can get fewer errors in runtime. And this was with TypeScript 2.0, which means that with TypeScript 4.0, which is coming out in the next, like this month, I guess, you're going to get even fewer errors for your end users because, well, TypeScript would have helped you to catch a lot of them. But of course, this is not the only benefit of the static systems. I already mentioned the zero overhead internationalization or even source code visualization and so much more. Now, since we're talking about Angular, not programming languages only, we're talking about frameworks as well, I want to put Angular and AngularJS on this axis. So back then, when AngularJS was released, which was, I guess, around 2009 maybe, businesses, they have different constraints. Businesses were building smaller web applications back then. And AngularJS was a very dynamic framework that was allowing them to move faster. They were just had to have a single script file that was your AngularJS source code, and from there you were able to build on top your AngularJS directives and so on and so forth. But over time things changed. People started building much larger applications, and we want to take advantage of the static guarantees that Angular provides, that these static systems provide. So that is why when originally the team started working on Angular version 2, we started with a very static and very restrictive system. It was great that it was catching a lot of bugs ahead of time, but also it was too restrictive and it wasn't allowing too much flexibility for the developers. So it wasn't providing great development experience. That is why we moved a little bit on the right towards a dynamic system. And remember, it is easy to go from static to dynamic, but it is hard to go the other way around. That is why we started with a static system, so that we can move to a more dynamic approach. With Ivy right now, I would say that we are close to the perfect medium, at least for now, because, well, the business is evolving, and we are providing some good compile time optimizations, translating your Angular templates to very efficient JavaScript instructions, and also we provide this zero overhead internationalization, which comes with its own trade-offs. For example, you'd have to refresh your page so that you can preview it in another language. But at the same time, you don't have to perform any data bindings and like change detection and whatsoever, and you're going to include the minimum amount of translations in your application. All right, so that was a theoretical foundation. I know that was a little bit abstract, so bear with me right now. I hope also you saw that what are some of the trade-offs that we have been balancing about. As I mentioned, Angular is in this kind of a unique position compared to some other frameworks where we have a compiler which is guarding us and helping us to build faster applications with fewer errors. Now, about what's new in Angular, I want to focus on two new things. In V10, we focused more on like stability and development experience, and also in trying to make the system even stricter so that we can make sure that you optimize your application better. We also focused on increasing the visibility in different ways. Let us first cover the opt-in strict flag that we introduced. So in version 10, you can create a new project with the Angular CLI by specifying also the strict flag, which is going to generate an Angular application that has some more like special configuration options. And this application with strict mode, we are making sure that we're enabling the strictest possible TypeScript type checking. We're also enabling stricter templates checks in Angular so that we can perform better type checking inside of your Angular templates. We're also disabling ES5 support by default, because we want to make sure that your builds are faster, right? We would want to ship only ES 2015 to your end users and skip the ES5 part. We're also disabling CommonJS. So if you would want to use CommonJS modules in your Angular applications, you'd have to explicitly configure the CLI to allow this. And we're also assuming that your application doesn't have many side effects. This is allowing Webpack to tree shake it more efficiently. We wouldn't be able to dig too much in depth in all of these. In the next couple of weeks, we should follow up with a blog post explaining everything in details on blog.angular.io. But I guess when you look at the strict mode, probably you're getting the overall feeling that you'll be getting more of these screens, right? You're getting just more errors in your console. But just a reminder, getting these errors is a good thing because your end users are not going to get these errors and you're going to spend less time fixing them and focusing on building new features instead. The opt-in CommonJS is, again, another example of the static versus dynamic trade-off. CommonJS modules, they were originally developed for Node.js environments. And they have some pretty dynamic behavior. You can load a CommonJS module from a location that you're getting from an expression that is like only available at runtime. So for example, you can send a request over the network, get a module name, and load a module associated with this module name. This is very, very dynamic, and it doesn't allow us to perform too many optimizations ahead of time, such as tree shaking. So that is why we decided to see how we can move the industry a little bit forward by making CommonJS an opt-in instead of allowing you to use CommonJS by default with like any projects. Our bigger motivation for this was that a lot of modules right now, such as Moment.js, for example, they are shipped in CommonJS, which doesn't allow us to tree shake them efficiently. There are many more details about why CommonJS is making your bundles larger and why you should probably consider using ECMAScript 2015 modules instead in this blog post at web.dev/CommonJS larger bundles. So you can get many more details here. Now, in the final part of the presentation, I want to focus on increasing the visibility. That is an effort that we have been moving on for a while. If you have noticed, last week, on the 6th of August, Jules published this blog post about the roadmap for Angular. I believe like shipping a roadmap for a front-end framework, this is kind of a new thing to us, and this should become a trend because it is good to give a heads up to businesses ahead of time and let them know what a team has been up to and what is their plan for the future. It also opens the engineering process more, especially for an open source project. This way the contributors would know what they should focus on, right? So if you have read this blog post, you have seen that our main focus is on stability, development experience, and speed. We have been like stable for a while now, and stability is very important for us. The open experience is also important, especially given some of the trade-offs that we're making, enabling some pretty tough practices for beginner developers, such as like using TypeScript, dependency injection, and having this compiler to slap you over your hands if you do something wrong. Speed is also essential, not only in terms of build time, but also making sure that we're producing the fastest applications possible by optimizing your templates and also by shrinking your bundles. So the current projects that we're focused on are test harnesses. These are just enabling best practices for you to develop unit and end-to-end tests when using Angular material components. This way, instead of coupling your test to the internal DOM structure of the components, you'll be able to use harnesses. And when we modify this internal structure to make the components more efficient, we wouldn't break your tests at all. Like you'll be just relying on these abstractions, so you can take advantage of them. TypeScript version 4 is another feature, so we're just keeping up with the industry standards here. This may not seem like a huge effort, but we're very tightly coupled to the TypeScript compiler because of the Angular compiler that we're building on top. So changes in the TypeScript compiler is breaking the Angular compiler, just like if we change the Angular public API, we're going to break applications, right? So we're keeping up with TypeScript version 4, and also we're going to evaluate our end-to-end testing strategy. This is an ongoing effort. It is a pretty large effort as well, and this is something that we're currently working on. MDC Web is another large effort. So in Google, we have like different material design component implementations. And the material design components that are developed with web components is kind of the industry standard. They're developed by the material team at Google. So we want to step on top of them to make sure that we are better aligned with the material design specification and we have fewer things to maintain. This way, we're going to wrap them in Angular components without having like any performance regressions for you. This is something that we have been really focused on to make sure that the bundles of the JavaScript components that we get at the end are not going to be higher. Trusted types is another such effort. This is a new API that browsers introduced to the web platform. So trusted API, the trusted types, they're aiming to reduce the cross-site scripting attack surface for web applications. We have been having a custom trusted type implementation for a while now. So by using Angular, you're already getting some guarantees that you wouldn't get hacked easily with a cross-site scripting attack, let's say. But since we implemented them, the evolution of the web has been moving forward, right? So we have these trusted types in the browser now, and we would want to take advantage of them instead of having a custom solution. We'll be working on moving forward with the evolution of RxJS as well, and also two of the bigger efforts are Ivy libraries. We have been getting a lot of requests from folks that they really don't love the NGCC experience because this is slowing down applications build time. And also they would want to ship Angular applications and like Angular Ivy libraries to NPM instead of going through this legacy view engine compiler. I'm going to talk about this in details in just a little bit. Bylock is also another large effort. This is our code name for just focusing more on the community requests on GitHub. So our goal for the Bylock is to reduce the issues across our three main repositories, the Angular CLI, the Angular framework, Angular/Angular, and also for Angular components. Currently, we're spending up to 50% in issue triage, and since we started, we decreased the number of issues on the Angular CLI with 30%, and we reduced the number of untriaged issues in the components repository to fewer than 40, I guess. I haven't checked this number over the past week, so it might be a little bit up or a little bit down. Now let me share what are we planning to do with Ivy library distribution. So let's suppose that you have this Angular app component. Usually when you compile this app component with the Angular compiler, you're going to get a bunch of Ivy instructions. But we really don't want to ship packages which have Ivy instructions inside of them to NPM. Because if we want to change the instruction set and make it more efficient, we wouldn't be able to do that. We're going to break a lot of libraries. That is why we're going to introduce published library flag to the Angular compiler. Instead of producing a list of Ivy instructions, it is going to produce a declare component construct that is going to have all the metadata for your Angular component. This is going to include the template of your component, also the metadata of your component's decorator in general, such as like view encapsulation, also change detection, and so on and so forth. Later on, we're going to allow you to distribute this to NPM. You can just take this JavaScript and publish it on NPM. When someone wants to download your library and use it in their Angular Ivy application, we're going to use the Angular linker that is going to translate this intermediate representation to an actual Ivy component. There are a lot of interesting details about this proposal, actually, and since we want to make our development and design process more inclusive with everyone, we ask you for your feedback. The form for feedback in this RFC, Ivy Library Distribution, is still open. So if you want to see some of the details of the implementation that we're planning to apply, or if you have comments about it so that you can help us to make it better and fulfill your use case as well, please feel free to comment on this RFC. We already got a bunch of very useful feedback that we're going to implement. So next week, we're going to share a summary of this feedback and proceed with the implementation. So make sure that you check this RFC out. So the final part of this presentation is about the future projects that we are going to be working on. This is not an exhaustive list of all the projects. We have so much more on the roadmap. These are just the efforts that we'll be able to take on in near future. And still, there might be some shifts because we're having these prioritization meetings pretty frequently. So when we publish our roadmap again during the next quarter, things might have changed a little bit. For example, you may notice that some projects have changed their order a little bit, or maybe you're going to see some new projects. There might be some missing, but in general, the roadmap should be consistent across quarters. So we're going to be migrating from TSLint to ESLint. There is a lot of great work that has been done by community already. James did some great work there in order to implement linting for Angular in ESLint. So we will be just evaluating what would be the best migration strategy of TSLint users to ESLint and moving forward from there. We'll be working on better forms, since this is the #1 ask from community, just having well-typed Angular reactive forms. This is on our roadmap. We'll be working on Webpack 5. This may seem like just another upgrade, right? But at the same time, Webpack 5 provides persistent disk caching. And, well, having faster builds has been one of the main requests we're getting from developers. We're working closely with the Webpack team. I'm talking to Tobias once in a while so that we can make sure that we align the Webpack 5 release with an Angular release as well. And this is something where we're actually doing some early exploratory work in. Optional zone.js is another effort, which is aiming to help us have better stack traces, reduce bundle size, and also just drop some of the constraints that Zone has been setting for us and making Angular in general simpler for people. We want to remove the current version of the Angular compiler. This is going to simplify a lot of the APIs in the framework, in fact, because previously, for example, if you think about it, in ViewEngine, we had this ng factory concept. If we remove ViewEngine because we no longer use it, we can get rid of such ng factory APIs since, well, we no longer have factories. This is going to make the API simpler, and it is going to allow us to move faster with Ivy and introduce more ergonomic APIs. DevTools has been an effort that I have been really excited about. I'm going to share a little bit about it in a bit, but we generally want to provide better development experience to people to understand their Angular applications better with tooling that is well integrated with the framework. Optional ng modules has been another very frequent community requests. A lot of people, when getting started with Angular, are confused with these ng modules. So we want to make them optional. If you don't want to use them, you don't have to. And finally, we're also planning to work on more ergonomic code splitting to allow you to ship faster Angular applications. So now just a few words about Angular DevTools. Some of the main features of DevTools that we're planning to introduce are a component explorer, very similar to Augury, where you'll be able to explore the internal component state and change some of the properties and see what is the result. It is also going to provide you a good overview of your application structure and much more. In contrast to what is available currently, though, we're also planning to introduce a profiler that allows you to understand your Angular change detection much better and see what is the performance bottleneck at runtime for you. Well, just wanted to reiterate one more time that this is what is coming up. And as you can see, we're really focused on keeping everything backward compatible. Stability is probably our highest priority. We also want to bet on development experience because making developers productive is from a very high importance to us. And finally, speed. Having faster builds and faster applications is always great. That was everything from me. I would really love your feedback about my talk on mgv.io/talk. And if you have more questions where we can go more in depth into this content or like anything else related to Angular or JavaScript in general, I would love to continue the chats in the Q&A session right after the talk or in social media on Twitter or even GitHub. Thank you.
Thank you very much, Minko. That was really cool. Really exciting to see what is coming on.
Yeah, there are also a couple of other exciting efforts that we'll be sharing in the next few quarters. I'm particularly excited about the features which are actually removing features, right? Making ng modules optional in Zone.js as well. This would be